Sometimes we have a redox reaction, a skeletal redox reaction, where there's oxygen on one side and no oxygen on the other side. And you might ask yourself, how are you possibly going to balance that if you don't have any oxygens on both sides of the equation? But never fear, these are typically run in aqueous solution, and so we always have water around. And if the solution is acidic, we have water as well as extra H pluses in our solution. So let's see how we can balance this skeletal equation knowing that it is in an acidic solution. We're going to go through the same series of steps that we always do for balancing redox reactions. So the first thing is to get rid of spectator ions. And this skeletal reaction is written in such a way that the spectator ions have already been removed, so we don't have to worry about that. So the next thing is to figure out which element is oxidized and which is reduced. And we can easily see that the iodine starts out as -1 and goes to 0. And so it has increased in oxidation number, so the iodine is oxidized. So we're going to write an iodine oxidation half reaction. And then we need to figure out the manganese oxidation states. And so we know that we have 2+ on the product side, and we can deduce that we have a 7+ on the reactant side. Each oxygen is -2, and there are 4 of those. So that's a total of -8 contributed by the oxygen. But the overall ion is -1, and so that means that the manganese must be +7 on this side, and it goes to +2. So it's been reduced from +7 to +2. So I know that my manganese is my reduction, and so I have manganate, permanganate, going to manganese 2+. Okay, the next step is to balance the element that is changing oxidation state. So for my oxidation half reaction, for the iodide half reaction, I've got 2 iodines on the product side and only 1 on the reactant side, so I'm going to need to multiply that by 2. For my manganese, I have 1 on the reactant side and 1 on the product side, and so that manganese is already balanced. The next step is to balance the elements that are not oxidized or reduced. And so here's where I start to run into trouble. It's easy for the oxidation half reaction because there are no other elements. But in the reduction half reaction, I have oxygens over here and no oxygens over here, so I have nothing to add coefficients to make oxygens on the product side. So that's where I recognize that since I'm in aqueous solution, I have lots and lots of water around, and I can add water wherever I need it. So I can put 4 waters over on this side to give me 4 oxygens. Now immediately when I do that, I end up with 8 hydrogens that I need to balance on the reactant side. So since I'm in acid, that means I have plenty of H+ around, and so I can simply add in 8 H+ to my reactants. So now all of my elements should be balanced. So I have 8 hydrogens, 1 manganese, 4 oxygens, and 4 oxygens. 2 iodines, 2 iodines. So the next step is to balance the charge. And we can see immediately that we have a 2- charge on the reactant side for my oxidation half reaction and 0 charge on the product side. So I'm going to need to add in 2 electrons to my products on the oxidation half reaction. If we count up the charge in my reduction half reaction, I've got 8+ plus a -1, so I have 7+ on the reactant side. And then on the product side, I have 2+. The water is neutral, and this manganese is 2+. So I've gone from 7+ to 2+, which means I'm going to need 5 electrons on the reactant side for my reduction half reaction. The final step is to add these two reactions together in such a way that the electrons cancel. So the only way to cancel these electrons is going to be to multiply this reaction by 5 so that I get 10 electrons in the oxidation half reaction, and multiply the reduction half reaction by 2 so that I also have 10 electrons in the reduction reaction. So if I do that and then I add things together, I'm going to have 10 I minus, because 5 times 2 is 10, 10 I minus. Let's make that an I minus. Let's see if we can erase this guy and make that a minus. There we go. Okay, 10 I minus, and then I have 2 times 8 is 16 H plus, and 2 times 1, so I have 2 permanganates. Okay, my electrons are going to cancel, and then I have 5 I2 plus 2 manganese 2 plus 8 waters. And that should be my balanced equation. So we can check to make sure everything's balanced. 10 iodines on this side, 5 times 2 is 10 iodines on this side, 16 hydrogens on this side, 8 times 2 is 16 hydrogens on this side, 2 manganese on this side, 2 manganese on this side, 2 times 4 is 8 oxygens on this side, 8 oxygens on this side, and in terms of charges, I have 16 plus 10 minus, that gives me a 6 plus, minus 2 more minuses, so I have a 4 plus on this side, and I have 2 times 2 plus is 4 plus on this side. So my charges and my atoms are balanced, and that is a balanced redox reaction in acid solution. But what if my solution is basic? If my solution is basic, then I have a lot of OH minus around, but I don't really have a lot of H plus around. And so the trick is that balancing things using OH minus and water is a little bit more tricky than using H plus and water. So what we're going to do is we're going to always balance it in acid first, and then use the equation that's balanced in acid. So we'll just use the equation that we already balanced, and we're going to change it into a base equation. So we'll do a little bit of magic here. And what we're going to do is recognize that water, since it acts as both an acid and a base, can be split up into H plus OH minus. And this reaction is going on all the time in the water. So I can add this, as many of these reactions as I want, into this reaction so that I cancel all my H pluses and end up with OH minuses. So what I'm going to need to do is multiply this reaction by 16, because I need to cancel 16 H pluses on this side using the 16 H pluses on the product side by adding 16 of these reactions in. So when I do that, I end up with 10 I minus plus my 16 H pluses cancel, but I have 16 waters plus 2 permanganates, and that goes to 5 I2 plus 2 manganese 2 plus, and now I have 8 waters plus 16 OH minus. Now the last thing I can do is to recognize that I have 16 waters here and 8 waters here. So I can cancel 8 of these waters with those 8 waters. So I can make this an 8, because 8 minus 16 is 8, and I can lose these guys, right? So my final equation is 10 iodide plus 8 water plus 2 permanganate goes to 5 iodine plus 2 manganese 2 plus 16 OH minus. And that is the reaction balanced in basic solution.